Welcome to Part 11 of Applied Chemistry, where we'll discuss about soil pollution and how we can control it. Soil pollution refers to the contamination of soil with harmful substances, resulting in a decrease in soil quality and health. This section will cover the following topics: composition of soil, classification of soil pollutants, effects of soil pollution, control of soil pollution. Soil is a natural body consisting of layers primarily composed of mineral particles. The solid portion of soil is made up of mineral particles such as sand, silt, or clay that are classified based on size. These particles affect soil texture, porosity, and water retention capabilities. Organic matter. Organic matter includes decomposed plants and animals, which enrich the soil by providing nutrients essential for plant growth. It also helps in water retention and improving soil structure. Water and air. Soil pores contain water and air, which are essential for the survival of microorganisms and plant roots. You can have better understanding of the composition of soil from this diagram. Soil pollutants can be classified based on their origin, chemical nature, and effects. They are primarily divided into two categories: inorganic and organic. Inorganic pollutants includes heavy metals contaminants such as lead, cadmium, arsenic, and mercury that come from industrial waste, mining activities, and fertilizers. And excessive salts, mainly sodium chloride from irrigation and industrial waste, which reduces soil fertility due to its salinization. Organic pollutants are the pesticides and herbicides, chemicals used in agriculture to control pests and weeds, can accumulate in soil, leading to long-term pollution. Oil spills and improper disposal of petroleum products can cause soil contamination, affecting its fertility and structure. Biological pollutants are the sewage and animal waste introduced into the soil can contain harmful bacteria, viruses, and parasites, leading to health risks for plants and animals. Radioactive isotopes from nuclear accidents, improper disposal of radioactive waste, and mining activities can lead to long-term contamination of soil. Soil pollution has far-reaching effects on both the environment and human health. Some of the major impacts include effects on soil quality. Soil pollution significantly alters the fundamental properties of soil. It leads to a loss of fertility as heavy metals, salts, and other contaminants change the soil's chemical makeup. This reduces nutrient content, making the soil less suitable for agriculture. Moreover, pollution can change the physical structure of soil, affecting its texture and porosity. This makes it harder for soil to retain water and support plant growth, further impacting agricultural productivity. Effects on plants and animals. Plants growing in polluted soil may struggle to thrive or absorb harmful substances. These toxins can then move up the food chain, affecting animals and ultimately humans. Soil pollution also disrupts the delicate balance of soil microorganisms. These tiny creatures play a crucial role in decomposing organic matter and maintaining soil health. Their loss can have cascading effects throughout the ecosystem. Human health hazards. The impact of soil pollution on human health is a serious concern. Crops grown in contaminated soil can absorb toxins, which then enter our food supply. This can lead to various health issues, including chronic diseases like cancer and neurological disorders. Additionally, contaminated soil can harbor pathogens that cause diseases, especially in areas where people come into direct contact with the soil. Soil pollution can be managed and controlled through a variety of techniques aimed at reducing, eliminating, or mitigating contaminants. These methods are classified into physical, chemical, and biological approaches. Physical methods include excavation and landfilling, where contaminated soil is removed and safely disposed of. While effective, This can be costly and may simply relocate the problem if not managed properly. Another physical method is thermal desorption. This process uses heat to remove volatile pollutants from the soil, which are then collected and treated. It's particularly effective for organic pollutants like petroleum products. Chemical approaches include soil washing, where the soil is cleaned using chemical solutions to remove contaminants. This works well for heavy metals and some organic pollutants. Another chemical method is stabilization and solidification. Here, chemical agents are added to the soil to reduce the mobility of pollutants, making them less likely to spread or be absorbed by plants. Biological methods offer a more natural approach to soil remediation. Bioremediation uses microorganisms like bacteria and fungi to break down or neutralize contaminants in the soil. It's an eco-friendly and cost-effective method, particularly for organic pollutants. Phytoremediation is another biological approach, using plants to clean up contaminated sites. Some plants can absorb or accumulate pollutants from the soil, effectively removing them over time. In conclusion, soil pollution poses significant challenges to our environment and health, but we have a range of tools at our disposal to combat it. From physical removal to chemical treatments and innovative biological solutions, scientists and environmental experts are working hard to restore our soils to health. By understanding this issue and supporting these efforts, we can all play a part in preserving the vital resource beneath our feet. We've reached the end of this video. Thank you for watching, and don't forget to like and subscribe for more tutorials on applied chemistry and other exciting topics.